Hi, this is Kenny Lee, and let's do a what if. What if the sun could collapse and become a neutron star? Like all of a sudden, like crunch down and become a neutron star. Now our sun cannot do this. It's not going to happen because the minimum requirement for a star to become a neutron star is about 1.4 times what our sun's solar mass is. So our sun cannot do this, but we can do a what if. And so let's take a look at this. So we don't need any fancy calculation like universal law of gravity, relativity, anything like that to actually get an idea about how large that a sun-sized neutron star would be. So we need to know, first of all, the density of a neutron star. Now they could vary. That's the Greek letter rho. It stands for density. And for a neutron star, its density is somewhere on the order of 3.7 times 10 to the 17th kilogram meters cubed. All right. Now our sun's density is nowhere near this, but if we could squinch it down to that density, then it would become a neutron star. Now, some neutron stars are more dense depending on their size of the original star when it started to collapse. But we're going to go with this one. This is kind of on the low end again. Well, the mass of our sun is 2 times 10 to the 30th kilograms. So that's the mass of our sun. And what we need to do is something really simple that you've done in basic science class. We got to do density. So density is equal to mass over volume. Now, volume of a sphere is 4/3 pi r cubed. That's the volume of a sphere. Because I know what's going to happen, I want to go ahead and solve this because we want to find the radius. We want to solve for r, and we got to get v out, which this v is volume. So that's density equals mass divided by volume. I want to move this out. So rho v equals mass. And then I want to get this v by itself, the volume by itself. So I want to divide by rho. So volume equals mass divided by density. Now the reason why I did that is because I want to have to substitute this in for the volume. And then we need to solve for r. So that's 4/3 pi r cubed equals mass over density. I need to solve for r, so I need to move this stuff over. So when I switch these over, this will actually flip. 3 will come up top, 4 will be on the bottom, and we'll have to divide by pi as well. So it looks something like this. R cubed equals 3m over 4 pi rho. Now I've got these numbers that I can plug in, and we can figure out what the radius is. So 3 mass of the sun is 2 times 10 to the 30th. 4 pi, I'm just going to use 3.14, times the density, which it has to be 3.7 times 10 to the 17th is our density. So if we solve that, 3 times 2 times 10 to the 30th, divided by 4, divided by 3.14, divided by 3.7 times 10 to the 17th, we get this number. 1.2911 times 10 to the 12th. But that is not the radius, that's the radius cubed. Now luckily on this calculator I have a cube root button, so I'm going to hit the cube root button. And that gives me the radius that our sun would be if it could scrunch down and become a neutron star to be 10888.9 meters. In other words, that's going to be about 10.9 kilometers. So the radius will be 10.9 kilometers for our sun if it was to be able to scrunch down and become a neutron star. Thank you for indulging me in this what if. Please like the video and subscribe to the channel, and I will see you again for some more physics. Goodbye.